that now? If you all notice it in last class, we discussed a concept called as work. So we all know that work is directly proportional to force and work is directly proportional to displacement. So if we combine these two one, so work or work done is directly proportional to force into displacement. And finally, we got the formula work done is equals to what, Amma? Force into displacement. This is what it is. So by this time, I have given you the diagram also. You might be take it for example. If there is an object which is moving from one place to another place, suppose there is a roller moving from this place to this place, it has been came here, and the applied forces, you can check it. So you can note always, this is the initial position, and finally it has been reaches to this position. So the displacement shown from here to here, this is what we will take it as S. Am I right, Lingesh? You have drawn the diagram also. Am I right? And the applied force is F. Applied force is what, everybody? F. Then is, as the force is applied, either push or pull, doesn't matter. Body is showing the displacement in the direction of what, everybody? In the direction of what? In the direction of applied force. If no interest, you can leave from the meeting, no issues. Applied force. In the direction of applied force, body is showing the displacement. Then we can say work is said to be done or not to be done. Everybody, work is said to be done. If applied force is 0, then work done is equals to 0. If displacement shown by the body is 0, then also work done is equals to what, everybody? Work done is equals to what? Please respond. Work done is equals to 0. So either applied force is 0, work done is 0. Next one, either displacement is 0, then also work done is 0 only. So that is what you have to remember it. Everybody clear? All of you? Mr. Darshan, Sanjay and all, I told you to join with a number. You don't understand? Sangamitra, you also give proper format. Hyphen is missing, check it. So either force applied is 0, then also the work done is said to be 0, or the displacement shown by the body is 0 also, work done is said to be 0. Alfin, understand Alfin till here? Any doubt? Clear? Now,
Yes, sir.
in our today's class, if suppose there is a body and the force is applied, for example, I will give you one toy to, let me take some of the boy from our, or else let me take the girl. So I'll ask, for example, let me take Agalya now. I ask Agalya to drag this car. Agalya, how you apply the force? For example, you tie a one rope and you will hold with your hands. Now you tell me, your applied force is parallel to the, see, displacement will be in this direction. Will you all agree with me, everybody? Will you all agree with me, Mr. Lingesh? Displacement will be in this direction as this girl is moving forward direction. But now you tell me, is applied force is parallel to the displacement or with the inclination? Check it, everybody. Is it with inclination or parallel to displacement? Anyone? Inclination. So by the time the applied force is not parallel to the displacement, it is with the angle. So then in this case, what is the work done? I already taught you people. You all remember that if this is the direction of applied force, resultant force, and it is making the theta angle, then here what will come? Anybody can tell? Already we have made. Then force will be splitting into two components. One is x component, another is y component. Anybody here what will happen? This will come what? F cos theta.
Cos
And
theta.
here what will happen? F
Sin theta.
Ellame familiar? Do you remember that or not? Everybody? Clear, everyone? That is what. So this is F cos theta, and this will become what? Everyone? F sin theta. Now, can you tell me, all of you observe, this one I can call it as applied force in the direction of displacement. How much it is? Anybody can tell? Applied force in the direction of displacement. What is that? F cos theta. Understanding, Amma? Applied force in the direction of displacement. How much it is? F cos theta. Clear, everybody? Here is the theta. Is it right or wrong? Am I saying right or wrong, Mr. Lingesh? Pranav? Understand, Agalya? So, direction of force. What do you mean by F cos theta? Direction of force in the applied force. Force applied in the direction of what, guys? In the direction of displacement is equals to how much, everyone? F. Please respond. F cos theta.
F cos theta.
That is what? What do you mean by F cos theta? Force applied in the direction of displacement. Can you tell me what is the F sin theta? Anybody? Force applied in the direction of what? Force applied in the direction of what? Y. This is F cos theta, force applied in the direction of X. But we know X is equals to what, everybody? X is equals to S, displacement. Am I right or wrong in this axis? Please respond, guys. All of you. Yes, everybody. So basically in any kind of object, when we are dragging, understanding, so we won't apply the force exactly parallel to the displacement. Parallel to the displacement. If both are parallel, can you tell me what is the angle between them? Anybody can speak? Angle between them.
0.
Angle between them is 0. Understanding, all of you? Now, if the force is applied with the inclination to the displacement, then the force applied in the direction of displacement will become what, guys? F. Respond. F cos theta. Okay. Work done formula. Work done formula, what is that? Work done is equals to what? We all know the formula. F into F. Then F is equals to what, guys? F is equals to what? Is not F. F is equals to what, everybody? F cos theta. So formula will turns into F cos theta into S. So I will write this one as a Fs cos theta. Is it right or wrong, all of you? Will you all agree with me? Yes. If the applied force is in the direction with angle with the direction of displacement, then the work done formula is how much, everybody? It is not Fs. It will become what? F dot S into cos theta. So that is what you have to remember. Anybody have any doubt in this? You can ask me. Clear, guys? Gokul, Raj, Hasini, everybody understand? Kishore, Lingesh?
Yes, sir.
Mr. Darshan,
Sir.
are you there in the meeting or not? Huh?
Yes,
Sleeping on. I told you to join with the name, number allotted. Your number allotted is what? 8. Theriyuma, theriyada?
no, sir.
I have sent you yesterday, correct? Check it. Mr. Sanjay,
Sir,
what is the number? Sanjay number is 22.
F cos theta is equal to distance only, no, sir.
What am I? F cos theta is not the distance, Agalya. Applied force in the direction of distance. Understanding? Applied force in the direction of distance. Clear? See, if anywhere force is applied with the inclination, that is called as resultant. Understanding, Agalya? If the resultant means, then the force will split into two components. One is x-axis, another one is y-axis. Okay, wow? So if here is the theta, then it will become, suppose the resultant force is F, then here it will become F cos theta, and here it will become F sin theta. Okay, Agalya? If suppose the applied force is inclination with the y-axis, for example, here is the theta, then here what will happen? F cos theta, and x-axis what will happen? Everybody? F sin theta. Okay. So force will be split into two directions, two-dimensional motion. Understand, Agalya? 2D motion.
Yes, sir.
Okay. So that is what? In the direction of applied force. Direction of applied force is Fs cos theta. Okay, wow? The force applied in the direction of displacement is F cos theta. So what is the work done formula? If I apply the force in inclination, everybody? Yes, please. Fs cos theta. Okay. Mari, join properly with the number. See the friends and see. Okay. Late already. That's what. Now, I'll give you one diagram. Alfin, understand or not? Respond, Alfin. So this is the diagram we'll discuss about when the force is applied with inclination. All of you check it. The body is initially at this point. Now, the force is applied with inclination. The force is applied with inclination. So here also you can check it. So after certain time, body is displaced to here. So from the center to center, the displacement of the body is S. and the applied force is F with inclination theta. So if it theta means, then what is the applied force in the direction of displacement? Everybody check it. This is the displacement. F cos theta. So work done is equals to F dot S. So what is the force applied in the direction of displacement? It is not F. Become F cos theta into S. So I can modify this formula F dot S into cos theta. So this is the work done formula when we apply the force in the direction of displacement, means with the inclination to the displacement. All of you remember this. Anybody having any doubt? You can ask me. Okay, guys. Please respond.
Sir, I can't understand it, sir.
Which one, Amma?
This one, sir.
Suppose, listen, Amma. If the direction is this, like this, for example, this is the object. If the direction is like this, means displacement, and the applied force also like this, both are same direction. Do you understand? Then work done is equals to both are same direction. F into S. That's all. Or we can say F dot S. Okay, Shivani?
Yes, sir.
Now, the force is not applying parallel to the displacement. Displacement is in this direction, and the applied force is inclination with the displacement. This is the direction of force. Understanding, Shivani?
Yes, sir.
So in this case, there is an angle between the displacement and the applied force. Then, in these situations, the force will split into the two components. Like friction cases, to applied friction, we have studied or not? Check your notes. In these cases, the force will be split into two directions. One is y-axis, another one is x-axis. So in x-axis, the force applied by object in the direction of displacement will become F cos theta. Here theta is there, here cos theta. Then opposite one, here it will become what? F sin theta.
Sin theta.
For example, can you tell me what is the normal here? Anybody can tell? Here, normal is equals to what? N is acting here. Understand, Mari? Normal is acting upward direction always. And weight of the object is acting what direction? Everybody. Weight of the object is acting what direction? Speak, everybody. Downward direction. So what is the weight of the object? Anybody can tell? What is the weight of the object? M into G. Right or wrong? Please speak.
Yes, sir.
Yeah. Now if you are taken, how many forces are acting upward direction? Check it, everybody. One force is already always acting normal. And now Y component also came. Y component is how much, everybody? Force, applied force. F?
Sin theta.
F
Sin theta.
And weight of the object is what? Weight of the object is what? Downwards. Mg. Okay. Then Mg is equals to this both. So Mg is equals to N plus F sin theta. Now from that, normal is equals to mg minus F sin theta. That is why we have been proved that pull is easy or push is easy. Pulling is easy or pushing is easy. Have you checked it?
Pulling is easy.
So now you tell me, this is push or pull? Force is applied in this direction. Push or pull? Everybody. It is what? Pull or push? Pulling. Understanding, Amma? We already done this. Verify your notebooks. Have you done? Understand, Shivani, now?
Yes, sir.
Yeah. So when the force is applied inclination, always the resultant, that is resultant force, means the applied force is in two directions. One is x-axis, another one is y-axis. So wherever theta comes, that will become F cos theta. Wherever theta not there, opposite one will become F sin theta. For example, here theta will come. For example, see, applied force is like this, and here theta will come. Then here what it will become? Everybody speak loudly, guys. Here what will become? Here will become F cos theta, and opposite one will become what? Here, everybody. F sin theta. Okay, ma? So wherever theta comes, that is F cos theta, and opposite one is F sin theta. Okay, understand, everybody? Agalya? Any doubt? Hasinis? Please remember that. This is what work done. Now, if this theta, three cases now: positive work done, negative work done, zero work done. What is that, everybody? Positive work done, negative work done, and zero work done. Okay. Now, all of you write that. Types of work done. Types of work done. Very simply, I'll finish it. You can see that. Types of work done. Alpha, no response. I called you 3 times till now. Types of work done. So work done is three types. One is positive work done, negative. One is positive work done, and second one is negative work done, and last one is zero work done. Okay. Actually, it is zero work done illa, work done by gravity. We will study that. Okay. So all of you observe very carefully now. Positive work done. So when I can say positive work done, all of you remember, if theta is less than 90. What is that, everybody? If theta is
Less
what?
than 90.
Less than 90 means then work done is 0. Means theta should varies from where to where? Speak all of you. 0 to
90.
than 0 and less than 90. That is a range of force, applied force. Then you will get work done is equals to what? Everybody respond. Work done is equals to
Positive.
positive. All of you. Work done is equals to positive. So what is the formula? Work done formula. Speak everybody. Fs cos theta. Okay, understanding amma? So Fs cos theta means, so cos theta is greater than 0. Then only work done is positive. Work done is positive. So when means cos theta is greater than 0. Cos theta is what? Everybody? Cos theta is greater than 0. Means angle must varies from 0 to 90 degrees. We'll solve the examples also. Then you can understand. Okay. Then negative work done means, keep it in mind, second case. If theta is greater than 90. If theta is what? Everybody? If theta is what? Greater than 90 means theta varies between 0 to 180 degrees. No 360. Reverse also same will come. 90 to 180. Then what is the work done, everybody? Please respond. Work done. Cos theta is less than 0. Cos theta is greater than 0. Positive work done. Cos theta is less than 0. Okay. Ma angle lakshanya, the applied angle force. For example, displacement is like this. And if you notice that angle is now perpendicularly means what is the angle, Amma? Perpendicular means what is the angle? Everybody. What is the angle of
90
perpendicular means? 90. So suppose if I draw like this, what is the
90 degree.
perpendicular means what is the angle? 90. Okay, wow.
90
Now,
degree.
if less than 90 means this is 0 degree and this is 90 degree. In between them, if it is force is applied, then work done is positive. Okay, ma? Please respond. Now, if suppose the displacement is like this, applied force is like this. Now, all of you check it, everybody. Applied force is this. Now, what is the angle? More than 90 or less than 90? More than 90 or less than 90?
More
This
than
is
90.
theta. This is 90. Now, this is theta.
More than 90.
Yeah, now 90 plus theta. Am I right or wrong? Everybody speak, guys. 90 plus theta means it is greater than 90. Greater than 90 means work done is what?
Negative.
Negative. You understand, all of you? Clear, Amma?
Yes, sir.
So cos theta is less than 0. Next, if theta is equals to 90, exactly. If theta is equals to how much? Theta is
90.
equals to how much? 90. Then keep it in mind. Cos 90 value I am giving you. Cos 90 value is 0. I will give you the values also now. Please learn that. Cos 90 value how much? All of you? Cos 90 value how much, Amma? 0. So work done is equals to 0. This is the three cases. Positive work done, negative work done, 0 work done. Please learn it. Anyone having any doubt, please ask me. If applied force and displacement angle is 90 degrees, then total work done is how much, Rasam? Total work done is how much? 0. Okay. So that is what. I will give you the values. Please note it, everybody. So only for cos theta I will give you. So in 11th class only you will study how to find the cos other values. Like some numbers only I'll give you. 9th class trigonometry you will get it. And 10th class trigonometry also you will get the values of perfect numbers. Some numbers only, not all the numbers. But in 11th class you will study how to find, how to calculate the other numbers like 10.5 degrees, 10.6 degrees, 15 degrees, 25 degrees. Like that values, how to find it. You will get it in the higher classes. Now I only will give you the few values. That few values alone you learn. Angle and the value. Okay, 1 minute, Amma. I'll give you. So please note it down. Angle and cos theta value. Angle 0, cos theta is 1. Cos 0 is how much, guys? Everybody? Cos 0 is how much now? You can find it.
93.
No, cos 0 means how much value? Cos 0, 1. Okay. Next, cos 30 value is root 3 by 2. Cos 45 degrees value is 1 by root 2. We'll solve numericals, then we'll understand. Cos 60 degrees value is 1 by 2. Cos 90 degrees value is 0. Cos 180 degrees value is minus 1. So please have this. Cos 0 is 1. Cos 30 degrees is root 3 by 2. Cos 45 degrees 1 by root 2. Cos 60 degrees 1 by 2. Cos 90 0. Cos 180 minus 1. Is it okay, everybody? All of you please respond. So this is the values, you all should remember that. Now, shall we start doing, all of you? Anybody?
1 minute, sir.
Yeah. So any doubt you can ask me. Above, I'm scrolling up. Till here, anybody, sir, you have doubt, you can ask me. Kishore, Shivani, understand Shivani? Nivedan?
Yes, sir.
Yeah. So please respond. Any doubt?
Yes,
Princy,
sir.
understand, Princy? Hasinis, Darshan, Alfin. I'm keep on calling, but Alfin won't say anything. Are you writing at least, Alfin? Now, we have studied the centripetal force and circular motion. How many of you remember circular motion? Yes, please. By the time I have taught you, anybody, always you remember direction of centripetal force. I have taught you centripetal force also. Am I right, everybody?
Yes, sir. Yes, sir.
So at any point, if I have taken direction of centripetal force and direction of displacement is perpendicular to each other. So can you tell me the work done by the centripetal force is how much? Anyone?
0.
Work done by the centripetal force. At every point, they are perpendicular to each other. So what is the work done by the centripetal force? Anybody?
0.
0. Because always the angle between them is how much? At any point.
90 degree.
90
degree.
So that cos 90 is equals to how much, Amma? 0.
0.
So work done by centripetal force, which is equals to how much, everybody?
0.
0. That is what. Okay. So very important. Write it. In uniform circular motion, is it interesting or not? All of you? In uniform circular motion, work done by centripetal force. Sanjay, Purima, Sanjay, Sam. Work done by centripetal force. It is not centrifugal force. Centrifugal means what? Centrifugal means another kind of force. Anybody?
Imaginary.
That is another force name. Centrifugal force means something name. Anybody? Nobody. Centrifugal force, another name called as? Yes?
Pseudo force.
Pseudo force. Yeah. Right. In uniform circular motion, work done by centripetal force is 0. Since centripetal force and displacement of the body. What is the angle? Everybody. Since centripetal force and displacement of the body, what they are perpendicular or parallel to each other? Yes, please. Sangamitrai, Purima.
Perpendicular.
Displacement of the body. Both are perpendicular each other or parallel to each other?
Perpendicular.
Or perpendicular. Lingesh, understand, Ara? Perpendicular to each other. That's all. Please write it. Any doubt, anybody can ask. Okay, guys, everybody. So what is the work done? Everyone? Work done is equals to what?
0.
0. So please make it. So this is what about it. Now, work done is positive when theta is varies between 0 less than theta. Shall we solve one numerical? Everybody, will you all agree? If I
Yes,
solve one
sir.
numerical, you all will be happy, I think. Shall we solve it now? Actually, this concept is your fourth chapter, work and energy. So we are going with the foundation. Already the second chapter of your school is completed. Nothing is there, including even we studied law of conservation of momentum and derivation for conservation of momentum also. Am I right or wrong? Everybody?
Yes, sir.
Yes.
Yes,
So your school syllabus is what? Only just Newton's first law of motion, Newton's second law of motion, and as well as what? Newton's third law of motion. That's all. So nothing is there. Okay, guys. So, but we have studied many things. So you all should have that importance also. Okay, shall we solve now, everybody? One question will solve. Okay. Now, I will give you the only diagram like 11th class. No theoretical question. You should solve. So there is an object in the floor. There is an object in the floor whose mass is m. Whose mass is how much? Whose mass is how much?
M.
M. Okay. So now, whose mass is m? Mass does not matter. Which has been shown a displacement of s. Displacement of s, which is equals to 5 meters. And applied force is 15 newtons. What is the applied force, everybody? F applied is 15 newtons with angle of 60 degrees. With angle of how much, everybody? With angle of 60 degrees. Okay, Kishore, values you want, you can write it. Who joined now? Late, this much late. Very, very bad. Danishka, I think. This much late, 40 minutes late. Completed, everybody? So can you tell me the work done, please? Work done. Work done. So what is the formula? Work done is equals to. Speak loudly. Work done is equals to. F yes cos theta. So F is how much? 15 into displacement is 5 into cos 60 degrees. Cos 60 value how much? Verify and tell me. Cos 60 value.
1 by 2.
Cos 60 1 by 2. Okay, wa?
1 by 2.
Cos 60 1 by 2. So 2 ones are okay, let it be. 15 5s are how much? 15 5s are
75.
75. So 75 by 2 if I make it. So what is the answer? 37.5. Okay. What is the unit of work done? Anybody can tell? Unit of work done, please. Unit of work done. Please. I think already school I have already taught them. Anybody? School unit of work done. Newton into meter. Work
Yes,
done
sir.
is equals to force is equals to. See, remember cos theta no unit. Cos theta what? Agalya? No unit. Now force. What is the unit of force? Newton.
Newton.
What is the unit of displacement?
Meter.
Meter. Newton meter. Newton meter only we used to call as joule. Of course, we'll study what is the unit of work done. Everybody? Unit of work done. Joule.
Joule.
That is what you studied. I think unit of energy is joule. Am I right or wrong? Everybody.
Yes, sir.
Unit of
Compulsion.
energy is joule. Keep it in mind. Unit of work done is also what? Work or work done is also what? Joule. Okay, ma'am. Yes. So please make it.
So
What is the
joule
answer?
is equal to joule is equal to Newton into
Meter square per second square. I'll say you, Mari. That I'll teach you. Okay, wa?
yes, sir.
Yeah. Please focus on this. Any doubt, Amma? Understanding? Now, how many of you know that transporting load like heavy stones and all when the people are shifting, have you noticed that they will apply the force in the back direction? For example, there is a big stone. There is a big stone. Have you noticed that the force which is applied by the coolie, they will apply the force from this direction? Am I right or wrong, Mari? Yes?
Yes, sir.
They will lift it so that this body will go forward direction. Am I right or wrong? Please speak, everybody. Apply direction force. Yes, I already taught you this one, inclination surfaces. Mr. Nivedan, check it, everybody. Like this force is applied, components. Okay, so the displacement is this one. Let me take the displacement shown by the body is 5 meters. Now the applied force F is equals, let me take 50 newtons. What is that? 50 newtons. And the applied force is almost, you can take it, for example, I'll take it as a 120 degrees. How much angle, everybody? How much angle? All of you?
120 degree.
120 angle.
120. Okay. So now, what is the formula? What is the formula? Anybody can tell?
Work is equal to F.
Yes.
Yes.
So cos 120 value,
Work is equals to Newton
if people
into.
don't know correct, I'll give you. Cos 120 value is minus 1 by 2, not 1 by 2, minus 1 by 2. So work done is equals to Fs cos theta. So F is 50, cos S is 5 into cos theta is cos 120. So cos 120 means what? Anybody can tell?
Minus 1 by
Yeah, 1
Minus
by
1 by 2.
50 into 5 into minus 1 by 2. So 51, 2 ones are 2 25s are. So 25 5s are 25 5s are 125. Okay,
125.
minus 125 joules. Work done is negative. Do you understand, everybody? Yes?
Yes, sir.
On. All of you clear?
Yes,
Amma?
sir.
Yes, any doubt? All
Sir,
of you? No. Okay, fine. Now another question.
doubt.
Ask me, Mari. 1 minute, Mari. I'll ask. Suppose, see, a ball is thrown upwards. A ball is thrown upwards. Now the applied force, the gravitational force is acting downward direction. Gravitational force is acting what? Everybody?
Downward direction.
Downward direction. Means, what is the displacement is in this way. Gravitational force is downwards. So what is the angle between them? Check it, everybody. What is the angle between them? 180 degrees. So work done by the gravity. Work done by the gravity, work done by the gravity on a ball thrown upwards, on a ball thrown upwards, thrown, THROWN, thrown upwards, is negative work done or positive work done? Upward
Negative.
is
Negative.
negative work done. Do you all understanding, Amma? Girls say, Hasinis?
sir.
Yes, that is what. Why means both are perpendicular to each other. Okay. Yeah. Yes, Mari, what is your doubt?
Sir, object pulling both to the topwards and from the downwards, it is the formula will be equal to it, sir.
Then net force is equals to 0, Mari. Both the sides it is acting, net force is 0.
Yes, sir. In the first question, the force is applied towards the top, sir.
Yes, Mari. This is pull and this is push. Have you checked it?
Yes, sir.
Yeah.
For both the push and pull, the formula is same.
Formula is same, but here angle is more than 90, so it is negative, and less than 180. Do you understand, Mari?
Yes, sir.
Yeah, that is negative work done, and this is positive work done. Now all of you understand, Amma? Everybody? Yes. Now, third question. Work done is 0. Shall we prove it now? Work done is 0. Everybody, question. Let me imagine now. There is a railway coolie. Okay, railway coolie who is carrying the suitcase. Suitcase theriyuma? Railway station, railway coolie will carry. Am I right or wrong? Anybody?
Yes, sir.
Yes, sir.
Yes. So now he is carrying. So applied force is upward direction. Am I right or wrong? He applied the force in upward direction. Will you all agree with me? Because he has to hold this. Am I right or wrong? With his hands. Nobody is answering. He has to hold. Applied force
Yes,
is
sir.
upward direction, and he will start moving in the forward direction. Suppose he started walking in the platform. Then can you tell me what is the work done? He is moving. For example, work done is equals to he's traveled 10-meter distance and he applied force on the load to hold that load. Let me take 10 newtons. Now tell me what is
So
the work done?
perpendicular downwards, sir. So 90
Yes.
degrees, sir.
So the angle between them. See, applied force is in this direction. The displacement is in this direction. But what is the angle between them? Everybody? Perpendicular to each
90.
other. So
Zero.
work done is equals
Work done is
to
equals to 0,
Fs
sir.
cos theta. So Fs cos theta 10 into 10 into cos 90. Cos 90 value how much? Cos 90 value 0. So totally what is the work done? Akalya?
Work done is
Shivani?
equals to 0 joule.
Now, here people will think work done by whom? We may expect. For 9th class, nobody will